morning, students. I'm Krishna Rao, Assistant Professor in CSC Department. I'm handling compiler design for 5th semester. In the previous classes, already we have discussed what is a compiler, what is an interpreter, what is the phases of a compiler, what is the advantage of front end, back end separation, and how the source file is converted by each phase of a compiler. Now we'll see the continuation of that one. So pass and phases of a compiler. So what is a pass? What is a phase? And that we discuss in today's class. The compiler will have 6 phases of and also a symbol table and as a handler. What is the task of the symbol table? A symbol table is a data structure which stores the information about each identifier and each variable. Here, that identifier might be a function, variable, constants, or data type fields. So, it will store the information regarding what is the type of the variable, what is the storage allocation, what is its initial value, what is the scope of the variable. All such information is maintained in this symbol table. Most of this information in the symbol tables is filled by the first phase of a compiler, that is lexical analyzer, and the information used and updated by all the remaining phases of a compiler. It is updated and also used by all the remaining phases of a compiler, right? So the main task of symbol table to store the information, and whenever it is required by any phase, it has to give the information. It has to be retrieved at constant time. So this symbol table also maintain the scope management, and also it helps for the other handler also. So in the same scope, when you declare same variable name once again, then this symbol table will use that the scope in the same scope duplicate variable is declared, right? So here for the symbol tables, we will use different data structures. One of them is hash tables. We use one or more hash table structures which will a efficient data structure for the symbol table. Normal linear structure we use, tree structure we use, or hash structures we use. So mostly the most efficient hash tables we use for the symbol table data structure. Next comes to the errors in the program. What are the different type of errors that occur, right? Here, the first one, common mistake, typing mistakes. Same variable name we may write at multiple places, but some places written typed correctly, but in some places we may mistakenly typed. Instead of normal characters, we may type a special characters which are invalid in the declaration of the variables. So the first one, the incorrect, misspelled the name of the identifiers. These are verified in the first phase of the compiler, that is lexical analyzer. Because the task of the lexical analyzer is to find, to read each character by character from the source program and group the lexemes into tokens, right? All such incorrect, misspelled identifier names will be found and verified in the lexical analyzer, right? Next comes to the missing semicolon, missing commas, all such syntactic errors, unbalanced parentheses, unbalanced flower brackets, open and close flower brackets, all such errors, syntactic errors, are found in syntax analyzer. Right? So here the syntax analyzer will follows the syntactic rules that are verified, that are represented by context-free grammars. Using that, every statement should end with a semicolon. So it will check every line is ending with semicolon or not. If any flower brackets are missing, unbalanced parentheses, or if you are declaring the multiple variables, it should be separated by commas. If they missed all such information, all such type of errors will be given by the syntax analyzer. Right? Next comes to the type mismatching, access and variable out of scope of the variable, are accessing an element from array over the it's the size of the array. So all such type of errors are given by semantic analyzer. Right? Type checking done by semantic analyzer. Right? Then logical errors. There are no errors in the program, but we won't get the correct output. Right? All these statements are written correctly, gives the output is wrong. Right? So there are some mistake in the logic. So that are different logical errors. Then exception handling. Right? So here we add additional code, extra code, where we expected any errors. So whenever we want to observe, we want to check a important code, we write in this exception handling. If any error occurred in that code will be caught by this exception handling, it will give a suitable understanding error messages with also specify some corrections also. So that in sometimes the execution goes to the next lines without disturbance. Right? Without halting, without stopping the compilation. Right? So the exception handling to handle the error messages, errors caused in the code. Right? So whenever we want some code to be suspect gives may errors, in such cases that important code might be written this exception handling to handle all such type of errors. So these are the different types of errors in the program. So there are two types of further there are two types of errors: static or compile time errors, runtime or dynamic errors. So static errors are reported by the compiler. Right? Here meaningful error messages it gives, and it will continues the compilation. Right? Here each phase of the compiler also needs some error handling routines. Right? Here error handling, the compiler will generate the complete list of error messages, and sometimes that different phases of a compiler also maintain some error handling routines to overcome these errors. So we know there are different phases of a compiler. Each phase of a compiler will do some task, and it will generate some type of error message also. So in that phase, they will contain error handlers also to without for not stopping the compilation process. It will rectify the errors and it will allow us to continue the compilation without break. Right? The first phase is lexical analyzer. Here, while we are constructing the lexemes and converting to tokens, if any errors occur, it will give the error messages. Here, for every programming language, it will have some character set. What type of a characters it will be accepted in that programming language. Letters are digits and specified special characters. If we say identify, then it will accept only the underscore and it won't accept any other special characters. Right? So, according to the character set, lexical analyzer will construct the lexemes and token. If it found any other special characters, simply any typing mistakes, it generate the other messages. Right? So that is a lexical errors. Then syntax analyzer. All the syntax rules are represented in the syntax analyzer. So every statement ends with semicolon. If we decline the multiple variables, it should be separated by comma. If it is a binary operator, it should have the two operands. If the union operator, there should be one operand. It will consist all such type of syntax rules will result to the syntactic errors. Missing of parentheses, unbalanced flower brackets, missing of the operands, missing of the semicolons, missing of the commas, all such syntactic errors are generated by the syntactic analyzer. In a programming, the most errors will occur in this syntax analyzer. Right? Then comes to the semantic analysis. In the semantic analysis, first of all, it will check the type checking, type compatibility. Here, if there is a statement syntactically correct, but it works properly or not, it has a meaning or not, it is required any data conversions, it will perform. Unable to do the data conversions, it will generate the error messages. If there is a binary operator, it must have two operands, but it should be same data type. One is float, one is int. Other smaller size data type is converted to larger data type, such that they will be converted to same data type and it will perform the float addition or float multiplication. One is a float variable, one is an integer variable, then integer variable converted to the float variable, then the both will be same type and results to the float addition or float multiplication. Right? So, if any type conversion is required, will be taken by semantic analysis. But further, it is unable to do the type conversions, then it will generate the semantic errors. Then intermediate code generator. So any mismatching of operands for an operator will be given by the intermediate code generator. So the task of the intermediate code generator, convert the syntax tree, abstract syntax trees to 3 address code or any intermediate forms. So while it converting any errors occur, it will generate the other messages. Then next comes to the code optimizers. So here it has to optimize the code, but results must be the same. If the results are affected, then it gives the error messages. Right? That is a code optimizer. Then code generator. Right? The code generator. Here, if any there is unreachable statements, the code generator gives the error messages. Right? Here, syntactically correct, meaningfully correct, but flow of control while executing will not reach the statements. then having such statements in the source program will not any use, will increase the size, but it has no purpose having that code. So we can remove all such unreachable statements. So that information will be given by code generator. Then symbol tables. In the symbol tables, it will store the scope information. If any same variable is redeclared in the same scope, then it will give the other message. The variable name might be the function name, might be variable name, might be a array name, a structure name. It should be unique in the same scope, right? So these are the different other messages that are given by different phases of a compiler. Next comes to the error handling routine by parser. Here, most of the errors are syntactic errors. So, here, whenever an error occurred, it will try to handle that error and recover that error, and it allows the passing the rest of the input. The main goals of this error handler is, if any error occurred, it has to report the errors clearly and accurately. It has to find the errors so that it try to rectify the errors, so that the compilation will be allowed to process. It will not be stopped. Here, it try to reduces the number of errors by specifying the rectifying procedures in the error handlers in each phase, because already we know what is the task of each phase, right? So in that particular phase, only such type of errors may occur. So there must be a procedures to rectify such type of the errors, right? To correct the programs. Next comes to the semantic errors. In the semantic errors, the main semantic analyzer will perform the type checking. You are assigning the proper values to the variables. You are using the proper variables with the operator. The type of checkings are done by the semantic analyzer. It will generate such semantic errors. Type mismatch, undeclared variables, using of the reserved keywords as variable names, multiple declaration of the variables in the same scope, accessing a value out of the scope variable, and mismatching of the actual and formal parameters. So all these are the different semantic errors, right? And the logical errors. Syntactically, semantically, properly compiled, but we are getting the wrong outputs. We are not getting the correct outputs. So, some logical errors that has to be rectified. The next important topic is phase and pass. Here, phase is a logically separatable task of the compiler. The task of separable task of the compiler. We refer as phase. Pass is one complete scan of the source program. The complete one scan, one traversal of the source program by the compiler. A pass may have one or more phases. A phase is a separatable logical task which changes one form of the source program to another form of the source program. A phase is which converts one form of the source program to another form of the source program. That we say as phase. Right? Here, a pass is a compiler will traverse, scan the source program completely one time. The pass may group more than one phases. Is clear? Phase is which a task, separatable task, which will convert the source program one form to the another form. Right? A pass is complete scan of the source program, complete traversal of the compiler through the entire program. Right? Here, the pass may have one or more phases. Right? Now we'll see the what is differences between phases of a compiler, passes of a compiler. Phases are the number of steps in the compilation process. The number of tasks, number of conversions, number of steps that is in the compilation process, in the compiler. Pass refers to the number of times the compiler goes through the source code. Pass refers to the number of times the compiler goes through the source code. It will scan the source code either one time, two times, and multiple times. There are some advantages and disadvantages with the one pass and multi-pass compilers. We'll discuss one by one. Here, phases comes to, there are 6 main phases of the compiler, that are the lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer, and code generator. Generally, we say the words single pass compiler, multi-pass compiler. What is meant by single pass compiler? It says that the single pass compiler says that in one scan of the source program, from first to last, it will convert to the machine code. It will convert from the source form to the machine form in one complete scan of the source program. Right? Means that it reads the source program only once, and it will convert all the phases, will act and converts one form to another form, and it gives the code. But the compilation is faster, but some features of the programming language will not be supported by single pass compiler. The first example is seal compiler is single pass compiler. For that reason, we need to declare all the variables at the starting of the source program, because it reads initially and fills all the symbol tables, operator tables, letter table, and everything, and used by any other phases. But if it comes to the Java, you can declare the variables anywhere in the source program. Right? Here you can apply a limited optimizing method in a single pass. If you use multi-pass, you can use multiple optimizing methods. Right? But if you use multi-pass compiler, it takes more time for the compilation. If you use a single pass, compilation is faster. Multi-pass takes more time. But multi-pass compiler will generate the efficient machine code. It will support more features of the programming languages. But if you use the single pass compiler, it may not support all the features of the programming languages. Right? It immediately translates each code section into its final machine code. Right? A two-pass compiler, a multi-pass compiler, if you have taken, then we can divide them as shown in the diagram. We know there are 6 phases of a compiler, but the initial 4 phases we are seeing as first pass, and the remaining 2 phases, code optimization and code generator, we are using as a second pass. Right? The lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator. These four phases is says as a single pass. The first pass will convert once that source program to intermediate representation. Then the second pass, which consists of the code optimization and code generator, will read the intermediate representation and gives to the final machine code. Right? So here, if we divide them, first pass and second pass, we can optimize the intermediate representation more efficiently, or we can move the intermediate representation one system to another system, one operating system to another operating system. It will support the portability. Right? So we use the second pass, which is restricted to the particular local machines, to convert to the low level language. So the first pass we refer as front end, our analysis part, our platform independent. These are the alternative names. We have already seen front end, back end. Right? Analyzer and synthesizer. Analyzer part, synthesizer. Front end and back end. The front end, our analysis, analytic part, our platform independent phase, our first pass is the same. It will include the syntax analyzer, semantic analyzer, lexical analyzer, intermediate code generator. These 4 phases, the lexical, syntax, semantic, intermediate code generator, these 4 phases are grouped as first pass. We refer as the first pass, front end, analytic part, or platform independent. Here, it will analyze these phases will analyze the high-level language programs and converts to the intermediate code representation. Here, these are the platform independent. The output of the first pass is intermediate representation. So, we can move from one system to another system, or one place to another place, and we can use the respective code optimization and code generator for of the second pass depending on the system. Right? So depending on the system, we'll use the code optimization and code generator. Right? Here, this code optimization code generator will have followed the machine instructions formats of the machine structure, assembly code statements, all such information. So depending on the which system we are executing, we use that particular second pass, right? The requirement is to change the code optimization and code generator. It will support platform independent by using of two pass compilers or multi-pass compilers, right? It will support platform independent. Then second pass. What is the second pass will consist? The second pass will consist the code optimization and code generator. We can refer these two phases as backend, a synthesis part, a platform dependent, right? So here already we discussed what is a backend, what is a synthesis. So it's the same thing. Here it will consist the code optimization and code generation. This will take the intermediate code representation as input, and the code optimizer try to increase the efficiency of the intermediate code, try to reduce the size of the code so that execution will be faster and also the efficient. Then it will send to the code generator. The code generator of the backend will follow the machine instruction formats, and it follows the on which machine it is executing its instruction sets, and finally it convert to the low level language or assembly level language or machine level language. So this backend or synthesis phase will convert the optimized intermediate code to the machine code, assembly code, or low level language code, right? So that is a task of the second phase. Here it is a platform dependent. Since the final stage of typical compiler converts the intermediate representation program into an executable set of instructions which is depend on the system. On which system we are executing program. So it must follow that instruction sets. Right? So this is the second pass is a platform dependent. Here there are advantages here. Each pass takes the result of the previous pass as input and creates the intermediate outputs. Therefore, the code improves the each pass. The final code is generated of the final pass will be more efficient. Right? Here, if we have the multi-pass compilers, we may separate them. Lexical and syntax as one pass, semantic and intermediate code generation as one pass, code generator and code optimizer as one pass. And also we can add the intermediate code optimization and code generator optimizations also, and machine independent code optimization or machine dependent code optimization also we can be added. So multi-pass compilers perform additional tasks such as intermediate code generation, machine dependent code optimization, machine independent code optimization also to improve the resultant assembly program and machine program is more efficient. Right? So that is the advantage of multi-pass compiler. We'll discuss one by one once again. To design a compiler for different programming language for the same machine. That is the first advantage of the multipass compiler. What we are saying, to design a compiler for different programming language for the same machine. Means the backend will have the same one respect to the machine. We will change the front end. So depending on the programming language, we use its respective front end. If the programming language 2, then we use its front end. If the programming language 3, we use its front end. Because the front end will give the intermediate representation which is independent of the source language, so that the backend will convert to the machine code works on the particular machine. So we need not to change the backend, right? So depending on the programming language, we will change the front ends. For example, a same programming language will be upgraded after some time. Version 1, version 2, version 3, version 4. Instead of constructing the complete compiler every time is a lot of headache. So we will update that particular front end only. If it is only the change in the character set, we only change the lexical alias of the front end only, so that the reconstruction of the complete compiler headache is reduced, right? So that is the advantage of having multipass compiler, right? So here we'll construct different front ends for each different programming language, but we'll use only one backend. Second one, to design a compiler for same programming language for different machines or system. Here, source language is same, so front end will be the same. So it will convert the source language to the intermediate representation. Then, depending on the machine, we use respect to backend. We'll modify only the backend for every version of the machine, or when any upgrade of the operating system, any upgrade of the machines, a change of machine, we only change the backend. We won't reconstruct the complete compiler, which is a difficult task, a complex one. So by dividing this front end, back end, a multipass system, we'll change only the backends. So here, for the same program, we have the same backend. So on which machine we are executing the programs, for the particular respective backends are changed. For machine 1, backend is 1. For machine 2, backend 2 is used. Machine 3, backend 3. So depending on the machine on which we are executing the programs, we follow its instruction set and we will apply in the backend, in the code generator, right? So it is avoiding the headache of the constructing the front end for every machine. So that is the advantage of having multipass compilers, right? So these are the differences. Speed, single pass, execution is fast, compilation is fast. Multipass, compilation is slow. When you say memory, single pass requires the more memory, because at any time, at every time, it has to maintain all the phases of the compiler, all the intermediate forms, source form and target form. All should be maintained at single time. So it requires the more memory. So multi-pass, it takes the less memory, because in the first pass it will have only the 4 phases and intermediate forms. After that, while we are executing the second pass, it required intermediate representation and only the code optimization, code generation, and final machine. So it requires less memory, right? So here the memory also will be affected. And execution compilation time. A single pass will take less time and multi-pass will take more time. Portability. Single pass will not support the portability. Either language portability or machine portability will not be supported by single pass. But multi-pass, it will be supports. And also it supports the most features of the programming languages. Right? So these are the differences between single pass compilers and multi-pass compilers. So depending on the system and its features of the programming languages, we select single pass or multi-pass compilers. Okay. So for today, I'm closing this section and we continue the remaining topics in the next class. Okay.
Like, share and subscribe. Hit the bell icon for more updates.